Good morning. In the last class, we were solving MCQs and we have finished till problem number 10. Both, even problem number 11 is finished. Problem number 11 was finished. Go to problem number 12. Radiations of two different frequencies whose photon energies are 3.4 electron volt and 8.2 electron volt successively illuminate a metal surface whose work function is 1.8 electron volt. Ratio of maximum speeds of emitted electrons will be. So according to the problem, radiations of two different frequencies illuminate a metal surface successively. Let us suppose this is a metal surface whose work function is 1.8 electron volt. The work function of this metal surface is given to us. This metal surface is illuminated by radiation of two different frequencies. Let us suppose this is radiation of frequency nu1 and this is radiation of frequency nu2. This radiation has photons having energies. The energy of photons corresponding to the first radiation is given as 3.4 electron volt. And the energy of the photon corresponding to the second radiation is given as 8.2 electron volt. See, the energy of photons in first radiation and the energy of photons in second radiation are given to us. Energy of photon in first radiation is 3.4 electron volt, whereas energy of the photon in second radiation is given as 8.2 electron volt. Work function of the metal surface is also given. We are asked to find out the ratio of maximum speeds of the emitted electrons. See, when light of frequency nu1 is incident on the metal surface, the kinetic energy of the ejected electrons will be k1. When light of frequency nu2 is incident on the metal surface, the kinetic energy of the electrons emitted will be k2. When the frequency of incident light changes, corresponding energy of the photon changes. We know that the energy of photon is equal to h into nu. When frequency of the photon changes, energy of the photon also changes, right? When energy of the photon changes, corresponding kinetic energy of the ejected electron should also change. We know that E is equal to W plus K. W is constant for a given material. So if E changes, correspondingly kinetic energy should also change. Now you need to calculate the ratio of maximum speeds of the emitted electron in these two cases. You need to first calculate speed of the electron emitted when light of frequency nu1 is incident, and you need to next calculate speed of the electron emitted when light of frequency nu2 is incident on the metal surface. Then you need to take ratio between them. See, we know that kinetic energy is given by half mv square. So v square speed, or speed square can be written as 2 times kinetic energy divided by m. 2 times kinetic energy divided by m. So speed of the emitted electron. Speed of the emitted electron is given by square root of 2 times kinetic energy divided by mass of the electron. This is the formula for calculating speed of the photoelectron. Speed of the photoelectron emitted from metal surface is given by square root of 2 times kinetic energy divided by mass of the electron. Make note of this formula. This is the formula used for calculating speed of the photoelectron. In order to calculate speed of the photoelectron, we need to know what is the kinetic energy of the photoelectron and we need to know what is mass of the photoelectron. In this case, we are given what is the energy of photon in the first radiation. We are given what is energy of the photon in the second radiation. We are given what is the work function of the material. ನಮಗೆ ಎನರ್ಜಿ ಗೊತ್ತು, ವರ್ಕ್ ಫಂಕ್ಷನ್ ಗೊತ್ತು. ಹಾಗಾದ್ರೆ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು? ವಾಟ್ ಕ್ಯಾನ್ ಬಿ ಡಿಟರ್ಮೈನ್ಡ್? We know energy of the photon, also we know work function of the metal surface. What can be calculated? ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು ಇಲ್ಲಿ? ನಮಗೆ ಕೇಳ್ತಿರೋದು we are asked to find out ratio of the speeds. Speed ಬೇಕು ಅಂತಂದ್ರೆ we need kinetic energy. Can we calculate kinetic energy? Can we calculate kinetic energy using the given data? We are given energy of the photon and we are given work function of the metal. Can we calculate kinetic energy? Can we calculate kinetic energy in both the cases? Can we calculate kinetic energy when photon of energy 3.4 electron volt is incident, and kinetic energy when photon of energy 8.2 electron volt is incident? Can it be done? Can it be done? No. We know that according to Einstein's photoelectric equation, energy of photon is work function plus kinetic energy. So kinetic energy of photoelectron must be energy of photon minus work function. Kinetic energy must be equal to energy of the photon minus work function. So kinetic energy of the electron in first case, that is when when photons of energy 3.4 electron volt is incident on the metal surface. Kinetic energy in that case will be 3.4 minus 1.8 electron volt. 3.4 minus 1.8 electron volt. This must be equal to 2.6 electron volts. 1.6. 1.6 electron volts. This is 1.6 electrons. The kinetic energy of the photoelectrons when photon of energy 8.2 electron is incident on the metal surface is K2 is equals to E minus W. Energy of the photon is 8.2 electron minus work function is 1.8 electron. Work function of the given metal doesn't change. 8.2 minus 1.8 is 6.4 electrons. 6.4 electron. This is the kinetic energies of the electron in two cases. We are asked to calculate the ratio of the speeds of the photoelectron emitted. You know that speed of photoelectron is given by square root of 2 kinetic energy divided by mass of electron. See, 2 is constant. Mass of electron is also constant. Ratio of the if you calculate the ratio of the speeds of electron. Ratio of speeds of electron, mass of electron in numerator as well as in the denominator will be the same. Mass cancel after that. 2 constant item 2 kuda cancel after that. So we can write speed of photoelectron is directly proportional to its kinetic energy. Speed of photoelectron is directly proportional to square root of kinetic energy. So if we have to calculate ratio of speeds of photoelectrons, the ratio of speeds of photoelectrons can be written as V1 by V2 is equals to square root of K1 divided by K2. V1 is proportional to square root of K1, V2 is proportional to square root of K2. That is equals to square root of 1.6 electron volt divided by 6.4 electron volt. We have calculated kinetic energy in first and second cases. 1s are 4s are 16 1s are 16 4s are. This will be 1 by 4 electron get cancelled with square root. 1 by 4 with square root. So this will be 1 by 2. So the ratio of speeds of the photoelectrons will be 1 is to 2. Ratio of speeds of photoelectrons will be 1 is to 2. V1 by V2 is equal to 1 by 2. So what is to be remembered here is the formula for speed of photoelectron. Formula for speed of photoelectron is 2 times kinetic energy divided by mass. Speed of photoelectron is 2 times square root of 2 times kinetic energy divided by mass. If you are taking the ratio, because mass of electron is constant and 2 is constant, you can just ignore this and consider speed of photoelectron to be directly proportional to square root of kinetic energy. Speed of photoelectron is directly proportional to square root of kinetic energy. Right? So ratio of speeds matter. You just take square root of ratio of kinetic energies. V1 by V2 will be square root of K1 by K2. K1 and K2 can be evaluated using Einstein's photoelectric equation. Energy of photon is used in two ways: work function and kinetic energy. work function is given, energy of photon in each case is given. First radiation has photons of energy 3.4 electron, next radiation has photons of energy 8.2 electron. Energy ಮತ್ತು work function ಗೊತ್ತಿದ್ದಾಗ kinetic energy easier calculate ಮಾಡಬಹುದು. Right, so the option here is 1:2. Second option is right. Second option. Just make a note of this. Speed of total electron is directly proportional to square root of kinetic energy. The formula for speed of total electron is V is equals to square root of 2k by m. Half m square formula use ಮಾಡಿದ್ರೆ ಬಂದ್ಬಿಡುತ್ತದೆ. Kinetic energy is equals to half m v square. So v square is equals to 2k by m. So v is equals to square root of 2k by m. So option is 2. Next note, problem number 13. Sodium and copper have work functions 2.3 electron volt and 4.5 electron volt respectively. Sodium and copper have work functions 2.3 electron volt and 4.5 electron volt respectively. Then ratio of threshold wavelengths is nearest to. You need to calculate ratio of their threshold wavelengths. It is given that work function of sodium is 2.3 electron volt, whereas work function of copper is 4.5 electron volt. You are asked to calculate the ratio of their threshold wavelengths. You need to calculate ratio of the threshold wavelengths. Okay? You need to calculate lambda s divided by lambda c. Lambda s divided by lambda c is to be calculated. Threshold wavelength of sodium to the threshold wavelength of copper. This is to be calculated. We know that work function can be written as h nu naught. Work function can be written as h nu naught. In terms of wavelength, work function can be written as hc by lambda naught. In terms of wavelength, work function can be written as hc by lambda naught. If you are taking the ratio, this h and c are constants. H and c are constants, so they get cancelled out. They cancel out the ratio. So how is work function related to threshold wavelength? This is not clear. Work function is inversely proportional to threshold wavelength. Work function of any metal is inversely proportional to its threshold wavelength. So now, if I calculate work function of sodium to work function of copper, we know that work function of sodium is inversely proportional to its threshold wavelength, and work function of copper is inversely proportional to its threshold wavelength. Lambda c divided by lambda s. We need ratio of their threshold wavelengths. Yavadadu ratio beku? We need ratio of threshold wavelength of sodium to copper. We need ratio of threshold wavelength of sodium to copper. Lambda s by lambda c must be equal to Wc by Ws. This reciprocate ಮಾಡಿ. I wanted lambda s by lambda c. This reciprocate ಮಾಡಿ, ಇದನ್ನು reciprocate ಮಾಡಿ. We know that the Wc, work function of copper, is 4.5. Work function of copper is 4.5 electron volt divided by 2.3 electron volt. 2.3 almost 2. 2.3 ones are 2.3 times 2 will be 4.6 into 4.5. So lambda s divided by lambda c will be equal to 2 by 1. Lambda s divided by lambda c will be equal to 2 by 1. Remember, work function is directly proportional to threshold frequency. Work function is directly proportional to threshold frequency, and work function is inversely proportional to threshold wavelength. These two relationships are to be remembered When work functions are given, you can calculate ratio of threshold wavelengths. When work functions are given, you can calculate ratio of threshold frequencies. Work function is directly proportional to threshold frequency, and work function is inversely proportional to threshold wavelength. So Ws by Wc correct. Ws is inversely proportional to lambda s. Wc is inversely proportional to lambda s. We were asked to calculate ratio of threshold wavelength of sodium to that of copper. So even lambda s by lambda c, Wc by Ws. Wc was given as 4.5 electrode. Ws was given as 2.3 electrode. So if you cancel it out, the ratio comes out to be about 2:1. Our nearest term the approximate cancel after the step. Right? So the option is 3. 13, 1, 3. Yes. So this is the option. Next number. Problem number 14. A graph is drawn between stopping potential and the frequency. Stopping potential is plotted along y-axis and frequency has to be plotted along x-axis. A graph is plotted between stopping potential and the incident frequency. Let us plot a graph between stopping potential along y-axis and the incident frequency, that is mu, along x-axis. Right? The intercept OA on x-axis gives 0.5 into 10 power 15 hertz. There is an intercept on x-axis, and that intercept is measured to be 0.5 to 10 to the power 15 hertz. Kinetic energy of electron emitted from the metal surface when energy of photon is 5 electron volts. First we need to know how or what will be the nature of graph between stopping potential and frequency of incident light. Can you tell me what happens to stopping potential if I go on increasing the frequency of incident light? If I go on increasing frequency of incident light, what happens to the stopping potential? You need to remember, if I increase frequency of incident light, kinetic energy of photoelectrons increases. Kinetic energy is directly proportional to frequency of incident light. If kinetic energy of electron increases, we need to apply more and more negative potential to anode to stop these electrons. So, as the frequency of incident light increases, stopping potential should also increase. Then, what should be the nature of the graph between these two? What should be the nature of the graph between these two? What should be the nature of the graph between these two? As frequency of incident light increases, stopping potential also increases. Okay, straight line on field theory. Straight line is right. Whether that straight line should pass through origin or that straight line should pass through, say, point A. Whether that straight line should pass through origin or it should pass from point A. Origin in the pass agala. ಯಾಕಂತ ಒಂದು ಸ್ವಲ್ಪ ಆಲೋಚನೆ ಮಾಡಿ. On x-axis we have plotted frequency of incident light. At origin, frequency of incident light will be 0. Will photoelectrons get emitted if frequency of incident light is 0? Will photoelectrons get emitted if frequency of incident light is 0? Electrons emit ಆಗ್ತಾವ. If frequency of incident light is 0, will photoelectrons get emitted? No. If frequency is, say, some 0.1 into 10 power 15 hertz, no photoelectrons are emitted. 0.2 into 10 power 15 hertz, no photoelectrons are emitted. 0.3 into 10 power 15, no. Photoelectrons get ejected from the metal surface only from one particular frequency. Feeling the photoelectrons emit ಆಗ್ತವೆ. As what is this particular frequency from which electrons or photoelectric effect is observed antadu, that frequency is called as threshold frequency. Andre up to a particular frequency you cannot expect photoelectric effect. Photoelectric effect agala, idu 0. Idu 0.25 into 10 to the power 15 hertz. Iಲ್ಲಿಂದ photoelectric effect start ಆಗಿರ್ತದೆ. From this frequency, photoelectric effect starts. There is a particular frequency of incident light below which no photoelectric effect is observed. Right? From this, if you go on increasing the frequency of incident light, ಅಲ್ಲಿ ಲಾ ಬರಿಬೇಕಾದ್ರೂ ಹಾಗೆ ಬಂದಿರ್ತೀವಿ. Above threshold frequency, kinetic energy of photoelectrons is directly proportional to threshold frequency. Kinetic energy of photoelectrons is directly proportional to frequency of incident light. From this point, if you go on increasing the frequency, kinetic energy of photoelectrons increases. If kinetic energy of photoelectrons increases, stopping potential also increases. So in the straight line graph, this will be the nature of the graph. This will be the nature of the graph. Up to this point, no photoelectric effect is observed. From this point, if you increase the frequency of incident light, kinetic energy of photoelectrons also increases, and correspondingly stopping potential will also have to be increased. We need to increase stopping potential from this point. ಈ ಇಂಟರ್ಸೆಪ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಇಂಟರ್ಸೆಪ್ಟ್ ನ OA ಅಂತ ಕೊಡ್ತಾರೆ. OA is given as 0.5 into 10 to the power of 15 hertz. ಈ ಯೂನಿಟ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ, this must be representing frequency. What frequency this is? Can you tell me what frequency this is? Up to this frequency no photoelectric effect is observed. ಇಲ್ಲಿಂದ ಮೇಲ್ಗಡೆ photoelectric effect observe ಆಗಿದೆ. ಹಾಗಾದ್ರೆ can you tell me what frequency is this representing? What frequency is this representing? So there will be no saturation point. There will be no saturation point for stopping potential in that graph. Saturation point ಬರ್ಬೋದು. Saturation point ಬರ್ಬೋದು. ನಮಗಿಲ್ಲಿ we are just thinking of variation of frequency with stopping potential. After a particular frequency of incident, right? As you go on increasing the frequency, stopping potential also goes on increasing. As you go on increasing frequency of incident light, frequency increase ಮಾಡಿದ್ರೆ electron kinetic energy increase ಆಗ್ತದೆ. electron kinetic energy increase ಆದರೆ ಆ electron ನ ಸ್ಟಾಪ್ ಮಾಡಲಿಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗಿರೋ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕೂಡ increase ಆಗುತ್ತೆ. That's the idea, that's it. So as frequency of incident light increases, kinetic energy of photoelectrons increases, and so corresponding stopping potential also increases. ಇಲ್ಲಿ ಸ್ಯಾಚುರೇಷನ್ ಐಡಿಯಾ ಏನಂದ್ರೆ ಸ್ಯಾಚುರೇಷನ್ ಕರೆಂಟ್ ಬರ್ತದೆ. ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ನೀವು ಸ್ಯಾಚುರೇಟ್ ಹೇಗೆ ಮಾಡ್ತೀರಿ? ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಸ್ಯಾಚುರೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. As kinetic energy of photoelectrons increases, you need to apply more and more negative potential. Stopping potential ಹೇಗೆ ಸ್ಯಾಚುರೇಟ್ ಮಾಡ್ತೀರಿ? Photo current can be saturated. Photocurrent can be saturated. As intensity of incident light increases, photocurrent goes on increasing. After reaching particular value, even if you increase the intensity of light, current remains constant. ನೀವು intensity increase ಮಾಡಿದಂಗೆಲ್ಲ photocurrent ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗಿ ಒಂದು maximum value reach ಆಗುತ್ತದೆ. Say 0 ಇಂದ 1 microampere, 2 microampere, 3 microampere, 4 microampere, 5 microampere ಆಗುತ್ತದೆ. Even after reaching 5 microampere, if you further increase the intensity of light, current does not increase. Photocurrent becomes saturated. Saturation, the idea of photocurrent na use ಮಾಡಬೇಕು with respect to intensity, not with respect to stopping potential. Stopping potentials na ನಾವು ಅಥವಾ stopping potentials cannot be saturated. ಅದು saturation attain ಆಗಲ್ಲ. ನೀವು kinetic energy of photoelectron increase ಮಾಡಿದಂಗೆಲ್ಲ stopping potential ಕೂಡ increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. Right? So what is this particular frequency of incident light below which photoelectric emission doesn't take place ಅಂತಂದ್ರೆ this is called as threshold frequency. This is called as threshold frequency. ಹಾಗಾದ್ರೆ ನಮಗೆ threshold frequency ಕೊಟ್ಟಿದ್ದಾರೆ. Energy of photon ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. What is energy of photon? Energy of photon is given as 5 electron volt, and you are asked to calculate kinetic energy of the electrons emitted. Kinetic energy of the electrons emitted should also be calculated in electron volts. Kinetic energy should also be calculated in electron volts. So this is threshold frequency. energy is given, threshold frequency is given, we need to calculate kinetic energy. Hagadre, what is to be done? When we know threshold frequency, what else can be calculated? We know energy of photon. We know threshold frequency. We need kinetic energy. What can be calculated now? What can be calculated now? ಏನು calculate ಮಾಡಬಹುದು? ಕೊಟ್ಟಿರೋ data ಇಂದ we know that kinetic energy of photoelectrons is equals to energy of photon minus work function. Kinetic energy is equals to energy of photons minus work function. So what can be calculated now? Energy of photon is known to us. 5 electron ತವರೆ ಕೊಟ್ಟಾರೆ. We can calculate work function of the metal. Work function calculate ಮಾಡಬಹುದು ನೋಡಿ. You know the formula for work function? Work function is given by h mu naught. Work function is given by h mu naught. H is 6.625 into 10 to the power of minus 34 into mu naught is 0.5 into 10 to the power of 15. So it is approximately 7 anta ankonಡ್ರಿ. 7 5s are 35. 1 decimal in that is 3.5 into 10 to the power of minus 19 joule. Minus 19 joule. But ನಮಗೆ kinetic energy electron volt ಮಾಡಬೇಕು. Energy of electron volt put the 5 electron volt ಅಂತ. ಹಾಗಾದ್ರೆ work function should also be expressed in electron volts. joule ಇಂದ electron volt ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ joule ನಾಗಿರೋ ಆನ್ಸರ್ ನ just divide it by 1.6 into 10 to the power of minus 19. joule ಇಂದ electron volt ಗೆ ಹೋಗಬೇಕು ಅಂದ್ರೆ divide this by 1.6 into 10 to the power of minus 19. If you divide it, the unit in which energy or work function is expressed becomes electron. 10 power minus 19, 10 power minus 19 gets cancelled out. 1.6 ones are 1.6 almost 2s are. Correct ಅಲ್ಲ? 16 2s are 32 ಬರ್ತದೆ. ಇಲ್ಲಿ 35 ಅದೇ approximate cancel ಮಾಡೋದು. 1.6 ones are 1.6 almost 2s are 3.5. So work function is now equal to 2 electron volts. Work function is equal to 2 electron volts. So kinetic energy of photoelectron is energy of photon is given to us 5 electron volt minus work function is calculated to be approximately 2 electron volts. So kinetic energy must be nearly equal to 3 electron volts. Kinetic energy of photoelectron must be nearly 3 electron volts. Is it clear? See, ನಮಗೆ ಆ ಇಂಟರ್ಸೆಪ್ಟ್ ಏನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿದೆ ಗೊತ್ತಿರಬೇಕು. Up to that point, no photoelectric effect is observed up to that particular frequency. So this frequency must be representing threshold frequency. If you know threshold frequency, you can always calculate work function. If you know threshold wavelength, you can calculate work function. hc by lambda naught ಆಗ್ತದೆ. So once you know work function, once you know energy of photon, energy and work function ಗೊತ್ತಿದೆ, you can calculate kinetic energy. So the option here will be 3 electron volts. 3 electron volts. Is this clear? Is this clear? Always remember, whenever you are plotting the graphs with frequency on x-axis, do not start that frequency at 0. At 0, you cannot observe any photoelectric effect. ಒಂದಷ್ಟು ಇಂಟರ್ಸೆಪ್ಟ್ ಬಿಟ್ಟು ಆಮೇಲೆ ಗ್ರಾಫ್ ಹಾಕೋದು ಅಂದ್ರೆ ಅಪ್ ಟು ದಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ no photoelectric effect can be observed ಅಂತ ಅರ್ಥ. At some point or at some particular frequency, photoelectric effect just takes place. That particular frequency at which photoelectric effect just takes place is called as threshold frequency. So this point must be remembered, right? So option here is 3 electron volts. Try to solve problem number 15, 16 and 18. 15, 16, 18 you solve ಮಾಡಿ. 17th ಮತ್ತೆ even 20th can be solved by you. 19th and 20th can be solved by you. 17th we'll solve it in the next class, please. We'll solve 17th problem in the next class. 15, 15 again, you just make use of this idea. Intensity is inversely proportional to square of the distance. This is the hint for problem number 15. Ali source ade source na emitter plate inda ದೂರ ತಗೊಂಡು ಹೋಗ್ತಾರೆ. If you move the source away from the emitter plate, what happens to the intensity of the light falling on the source? Or what happens to the intensity of the light falling on the emitter? If you move the source away from the emitter, what happens to the intensity of the light falling on the emitter? Decreases. How does intensity depend upon distance? Intensity is inversely proportional to square of the distance. Hagadre, if you have increased the distance, or if you have moved it halfway away from the emitter, the intensity must have decreased by 4 times. Distance given on increase ಮಾಡಿದ್ರೆ half increase ಮಾಡಿದ್ರೆ 4 times just there. Correct ಅಲ್ಲ? ಅಥವಾ if you have decreased it by 4 times ಅಲ್ಲೇನಂತ ನೋಡಿ, when same source is placed halfway away, if distance is decreased, intensity has to be increased, right? So make use of this relationship and try to solve that question. Intensity is inversely proportional to square of the distance, right? Intensity ಏನು represent ಮಾಡ್ತದೆ ಅಂತ ಹೇಳಿನಿ. Intensity represents number of photons present in the light. More is the intensity of light, more are the number of photons incident on the metal surface. We know that each photon is capable of ejecting only one electron. Intensity of light ಕಮ್ಮಿ ಇದೆ ಅಂತಂದ್ರೆ ಕಡಿಮೆ photons ಬೀಳ್ತಿದಾವ metal surface ಮೇಲೆ ಅಂತ ಅರ್ಥ. If 10 photons are incident, only 10 electrons will come out. If 20 photons are incident on the metal surface, 20 electrons will come out of the metal surface. More is the intensity of incident, right? More is the number of photons incident on the metal surface. Intensity ಜಾಸ್ತಿ ಅಂದ್ರೆ probably 1000 photons may be incident on the metal surface. If 1000 photons are incident on the metal surface, 1000 electrons will come out. 1000 electrons will come out. So, if the distance between emitter and the source have decreased, the distance between emitter and the source have decreased, intensity of light must increase. Intensity of light increase ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ more number of photons are now incident on emitter ಅಂತ. More number of photons are now incident on emitter. If more number of photons are incident on emitter, more number of electrons must be ejected out. More number of electrons must be ejected out. So using this idea, try to solve that problem number 15. Problem number 16 is regarding calculation of wavelength of incident light. Try to make use of Einstein's photoelectric equation there. Problem number 17 ನಾನು ಮಾಡಿಸ್ತೀನಿ. Problem number 18 is again calculation of maximum kinetic energy. Stopping potential ಕೊಟ್ಟಾರೆ. Kinetic energy is equals to EV0. Kinetic energy is equals to EV0. Use that formula for solving problem number 18. Problem number 19 is again on stopping potential. You can make use of kinetic energy is equals to EV0 given there. Corresponding again use of nobody. Problem number 20 can also be calculated even it is on stopping potential. So try solving this. We'll solve problem number 17 and the remaining problem 21 problem in the we'll start solving in the next class. Right? And in doubt bantantandre you can just explain. 15, 16, 18, 19, 20. 17 we'll solve in the next class. Thank you.